Do another division. This one here, again, you always look at it and make sure that there's nothing missing, right? We're trying to fill in the missing zeros if there are any. This has 4 x's, 2 x's, 1 x, no x. So we do need to fill in here 0x to the 3. Right? So it'll be 4, 3, 2, 1, none. This is 1 and none, so that's okay. Right? So you do have to fill in, it's the placeholder, right? So you need to, otherwise they won't line up when you're doing your subtraction. So we're going to do this. On the outside is the 2x plus 1. And on the inside is this guy here. So we're going to go 6x to the 4. Please do the 0x cubed minus 4x squared minus 9x plus 4. That's long enough. Okay. So we're going to do this again, just making sure we understand the pattern. And for this one, for your pleasure and enjoyment, we're going to get fractions or decimals. It is a terminating decimal, right? So you will be able to go to decimals. If it's not, technically you always have to stay fractions, otherwise you're approximating, right? So I did give you a nice fraction, which is a terminating decimals, so we can go to decimal. Okay, but I just want to show you it works even if it's not always an integer, okay? So we've got here. First into the first, I'm going to grab this one here. So you take the first big one into the first big one, and we go 6x to the 4 divided by 2x, right? So when I get that, I cross off the 2 into the 6, so I get 3, or I'll do this, 3, and the x, so it'll be x cubed. Okay, that, you go here. If there's 2 terms, I put it over the second one, and that would be 3x cubed. Okay, that matches, right, the x cubed. We're going to multiply it, right? You don't have to show this arrow, but you're going to multiply it here, right, times both of them, both of those, both terms, and then you're going to write it under here. You don't have to show the arrows, but it's both of those terms are multiplied by the 3x cubed. So 3x cubed, there will be 6x to the 4, and times the 1, so 3x cubed. And we're going to do this, and a minus, bracket both of them. Make sure you're subtracting both of them. Okay, so then we're going to do subtraction. When you subtract these absolutely have to cancel away to 0. We chose it that way. So it should be exactly the same 2 numbers. And if they aren't, you did something wrong here. Okay? You don't have to show me that, but yeah, that's on the side. So that should be 0. You don't have to put the 0. You can just cross it off. Okay? Here we're going to get, I'm just using a different color so it's easier to watch. So 0 minus 3, so it'd be negative 3x cubed. Drag this one down, minus 4x squared. Okay? So then you're going to do it again. So you're going to take this one and go negative 3x cubed divided by the 2x. And this is the one where if it doesn't divide nicely, and this one ends up being a nice decimal, right? So I gave you a nice terminating decimal. You can leave it as a fraction, 3 over 2. 3 over 2 is a beautiful fraction. I know some people are like, oh, I don't want to do a fraction, but you can write fractions on there. That's fine. So you can leave it 3 over 2, cancel out the x's. I will switch it to negative 1.5. Okay? So if you're good with decimals, you can leave it as a fraction as well. Okay, so that's negative 1.5, so negative 1.5x squared. Right, you can see the x squareds match up. Then you multiply with both of them. Right, multiply with both of them. And we're going to go like this. I'm going to go red, so it's going to be multiply that times that. So I'm going to get negative 3x cubed. This times this, negative 1.5x squared, like that. let's close that. And then we want to subtract, right? So make sure we subtract and both of them. This should automatically always be gone, right? So 0, because it's exactly the same. So you don't have to write the 0. You can if you want. This is negative 4 minus minus. So that'll be negative 2.5 x squared. Okay, and again, you can leave that as a fraction, right? If you're like, oh, don't like it, then I'll let you go to decimal. So drag this one down. Okay, next one, we're going to grab this, and we're going negative 2.5 x squared divided by the 2x. And that gets me negative 1.25x, right? 2.5 divided by 2. So there we're going to go negative 1.25x. Right, so it works even with numbers. Okay, so multiply that, and you should get exactly the same number, right, which we do. And then negative 1.25x. And this question, I was just trying to show you it works even if it doesn't work out perfectly like an integer. Okay, so it still works. So this, I'm going to go minus both of them. Okay, don't forget the minus, and it's for both of them. Okay, last one, I think. Yep, one more time. So I always look, I'm like, one more time, and then we're there. Okay, so this, 0. This will become positive 7, negative 9, negative 7.75x. Drag this down, plus 4. Oh, one more time. So I left all this room. So we're going to go negative 7.75x divided by 2x. And that gets me negative 3.875, which is just over an 8, right? Like it's actually a nice fraction. It wasn't a bad fraction, but keep all 3 decimal places because it's terminating decimal. It's an eighth, right? That shows me that's an eighth, right? We get eighths on this one, so it goes from half to quarters to eighths, right? So it's not a bad fraction, but if you don't want to, you can use decimals. And if not, it's half, quarters, and then eighths. You're dividing by 2, right? So you can say that's 0.5, 0.25, and 8.875. Okay, so drag that over here. We're going to do negative 3.875, and that's negative 7.75x minus 3.875. And again, just showing you it works with any numbers, right? So this will be 7.875, and that's your remainder. As soon as it's degree less than the x, then that's good. This is part F of the example we started before. So this question asks you to write it as a multiplication statement. If I don't ask you for that, then you can stop here. I don't need to see this on the side. Okay, you don't have to show that. You can if you want, but you don't have to. I just look up here to see what your number was. So those numbers are these numbers. Okay? Because it's question F of that same example, it's asking me to put it in as a multiplication statement. So you go dividend, so 6x to the 4. Okay? You don't have to replace the 0 there, right? So you don't have to replace it when you're rewriting it. Equals the divisor, which is 2x plus 1, times this beautiful quotient here. The hardest part is not copying it wrong. So there you go. I mean, not the hardest part, but okay. And then my remainder is this. So it'll be plus 7.875. Just to separate the two. Okay, any questions? Yep.
The fraction that was greater was like one that had like a repeating
Yeah. Then you should keep it a fraction, yeah. Because technically, once you've rounded it, then your whole polynomial's rounded, yeah. That's why. Okay. And you can see if it's divided by 2, it goes from a half to a quarter to eighths, right? So it should be, if this was thirds, divided by 2 would be thirds, sixes, and less. So it wouldn't be awful. It's just most people are like, it feels like funny, but you just keep that in fraction form. Okay? But if not, decimals are fine as long as it's terminated. All right? So it works with any such numbers. We'll stop there, and then we'll do, you can see ahead, we're going to do 3, and then on the next page we do x's and y's, like what happens if there's 2 variables. Okay, so we'll stop there for now.